So today we are going to do an introduction to water rights before that lecture. Today's introduction to water rights is really focused on water rights generally, not just California. So we'll do some California work, but then talk about water rights more broadly. And then, as I said, Professor Harder will be here on Monday to give us the detailed version of California water rights. So you want to know both of these, but it's helpful to have this kind of broader history, I think. So we'll talk about first kinds of water rights, and then different kinds of water appropriation systems, ways that we allocate those rights among individuals, and then, decide which rights to use within a system. And then Professor Harder will focus on just one kind of water appropriation system, the kind we use in California, and give you really the detailed case study of that system. So water rights, as many of you know, as hopefully you got from the reading, this is really the right to use water. It's not owning the water itself. It's not like owning the drops of water. So it's not a traditional property interest, but it is a real property interest. This is a huge issue in the West, has been for a very long time. When we talk about the West, we generally talk about west of the 100th meridian. So if we look at a map of the United States, this is a precipitation map showing how many inches, essentially inches of rain equivalent you get per year. And that's, you convert snow into rain to figure out how the inches of rain equivalent. And if you draw a line down the 100th meridian, that line runs about right there. So kind of straight through Nebraska, middle of Kansas, just east of the panhandle of Oklahoma. And I know you can't see the index here, but when you start getting to this orange color right here, you're looking at 15.1 to 20 inches of rain per year. And then that tan-ish color is 20.1, so this section right here, 20.1 up to 25 inches per year. You need roughly 22.5 inches or 22 inches of rain per year to grow wheat without extra irrigation. You need that to come during the right part of the year. So in the Midwest, we always joke about you're only 2 weeks away from a drought, right? Because if it stops raining at any point and doesn't rain for 2 weeks, then whatever you're growing has a good chance of dying if you don't have irrigation set up. So you need that rain to come in a fairly even way throughout the year. But if you have it evenly spaced, then 22 inches is going to be enough to grow crops. So looking at that line, our 22-inch line is somewhere in the middle of that lighter tan section, and east of there, you can generally grow your crops without external irrigation. So west of that line, we've been very concerned about water rights, about irrigation, because you need it to do agriculture in most of those spaces. Even in California here, where we have the areas that are green, even up in Oregon, those places have really bunched distributions of water. We'll talk about California a little bit, or Professor Harder will. Most of that rain falls during the cold season, rainy season. So you don't really get it during the growing season. So even in those places, you really need irrigation to have successful agriculture. This is increasingly important because of climate change, especially in the West. We tend to get rainfall less often, tends to be more intense rain events, but that's also true in the eastern part of the United States as well. We have population pressures, we have increasing use of the water resources there, and we have rainfall getting less frequent and becoming more intense during the rainfall events that we have, which means that you're more likely to have those droughts, have those periods of at least 2 weeks without rain. And when you have that, in areas you don't have irrigation set up, it becomes a real issue with how you keep your stuff alive. And so we're introducing irrigation in some of those eastern areas, and that brings up these same water rights questions. So this is super important to us, obviously, here, but it's also kind of important writ large throughout the West and becoming more important in the eastern United States. So there are three main kinds of water rights: riparian water rights, appropriative water rights, and Federal Reserve water rights. We have separate rights that cover groundwater, and everybody does groundwater a little bit differently. Everybody does surface water rights differently. These are property rights, which means they're decided at the state level. Right? There's very little federal influence on how water rights systems work, which means as soon as you go across the border into another state, you've got a different system of water rights to look at. So it's very state specific, and we can talk kind of generally about what folks do with surface water rights. Groundwater rights seems to be all over the map. Some states have done a really good job addressing those. Some states really haven't addressed them at all. California was in that latter camp until just a couple of years ago when we passed SGMA, the Sustainable Groundwater Management Act, which seeks to address groundwater, although it puts off kind of really severe regulation of that groundwater for another 10 or 15 years-ish. But Professor Hart will go into that more tomorrow. So right now we're talking about these kinds of water rights and not so much about the systems, and we'll switch over to systems of how we allocate these in the second part of the class. So as I said, these water rights are real property, but they aren't the right to these individual drops of water. You don't own the drops of water. These water rights are usufructuary, which means they are a right to use the water, but not a right to own the water. So right to use, not to own. The waters in general are owned by the public of the state where you're using those waters. Because this is a right to use, not a right to own, it gives an element of continued state control, continued public control, and some limits on the right to sell that water. And clearly there are cases when you can bottle water and sell that water. We buy bottled water all the time. But generally what we're talking about when we talk about this is a right to use that water, not a right to own the specific particles of water. So we'll start with riparian rights. Riparian means relating to or living or located on the bank of a natural water course, as in a river, or sometimes a lake or a tide water. So in ecology, you talk about riparian habitats. Those are habitats next to a stream, next to a river. You know, it's what you imagine when you imagine like that bucolic stream going through the countryside. You've got cattails, you've got willow trees draping out over the water, you've got cottonwoods growing there. All those signal riparian habitat. And so when we talk about riparian rights, we're talking about rights that relate to living on or being located on the banks of a natural water course. So these only come with an actual physical piece of property that butts up against water. These are really old water rights. This is how we've done water rights historically. This was the English common law system, and because this was the English common law system, it was also the system used in the eastern half of the United States when we first kind of became the United States. So we imported this system wholesale from England. England, wet or dry? Yeah, it's a pretty wet spot, right? Nice fogs and rain coming in off the Atlantic and people walking around in their wellies and all that stuff. It's a wet spot. Eastern United States tends to be wet. And so this system works pretty well in places like that, in wet places where we don't depend on irrigation for agriculture. So the legal access to this water is limited to those who own the property contiguous to a water course. You can think about these as the river runs through it rights. Yeah, if you haven't seen this movie, you should go watch it and start fly fishing. It's so good. And it's a young Brad Pitt. I mean, easy on the eyes, right?
Best Brad Pitt available.
Not bad. And it's fly fishing. It's pretty great. All right, so pure riparian water rights are part and parcel with the land. If you have a plot of land that gives you a riparian right, you cannot sell off that right. It's not severable from the land, and these are not gained by use or lost by disuse. People call them rocking chair rights, because you can just sit in your rocking chair and keep your rights. That right is always there. They can only be used in the riparian watershed, not sent out to another watershed. They're not transferable in that way. And after you use the water has to go back into the natural water course for use by downstream riparian landowners. So we've talked a little bit about watersheds. You've got a river, streams flowing into that river, and then you've got a mountain. This looks like a leaf. But this is a mountain here. We'll put some snow on it. This is a mountain range around the watershed. A drop of water, any drop of water that falls within this watershed is going to flow down into this river at some point, right? So this whole thing is the watershed for this big river, and you've got little watersheds within this river. And then over here on the other side of these mountains, you'll have another watershed. And if a drop of rain falls on the other side, it goes down into this watershed. Everybody's got watersheds? We're okay with that? Cool. All right, so here we've got a little stream that flows through. People settled this, they claimed up a bunch of different properties along here. So we have properties, okay? If you own one of these properties, property A, B, C, or D, and this property actually adjoins this waterway here, then you have a riparian right to use water from that waterway. You can't sell off that water right. You can't put a pump in here, take that water, and send it out of that watershed. None of those things are allowed. Okay? And if you sell part of your property, you divide your property, generally this half, unless you have some contract or something, the default is that that half loses the riparian water right. It stays only with the part that butts up against that river. You don't have to be using it to have this water right. It doesn't get extinguished because you're not using it. And that's really important to remember because that's going to be different than some of these other rights that we see. So these are restricted in a number of different ways. First, you're limited to the natural flow of the river, meaning you can't go out and dam up the river to increase the amount of water available to you. And you're not supposed to impact the downstream user of that water. Okay? So you cannot create a dam with a riparian right. You have to have an appropriate right to create a dam. These are generally subject to a reasonable use doctrine as to among the riparian rights holders. So you're allowed reasonable use of the water on your land, reasonable method of use, reasonable method of diversion. You can't use the water in an unreasonable way. And that reasonableness question is very fact-specific, considering all aspects of use, other potential uses of that water, what's going on kind of broadly in the watershed. And so that becomes it's a difficult call to make up front. Yeah?
Do you have the right to exclude others from using like a portion? So like, I mean, if you own a portion of the river, can you exclude people, or I guess throw up like some kind of barrier?
So are you talking about exclude them from using the water or exclude them from like floating on the river to fish?
So specifically, so like Tahoe, you see people who have the docks that extend out. If they were to throw out some kind of buoy that created some kind of personal swimming area, is that
interesting?
Or
on the California side, almost certainly not. Probably illegal to do that. That gets into access. That's I mean, it's slightly different than a water right? Because that's talking about a right of access to use these places, which comes up a lot more under the public trust doctrine. But generally, at least in California, we have very liberal public access laws for streams. So anything that's considered navigable, and navigable for access purposes means you can get down it during any part of the year in any kind of a craft. So if you can go in during the height of rainy season in like a big creek and kayak and float down, banging off the rocks everywhere, that still counts as navigable. And that means that stream is open to public access throughout the year. There's some questions about whether you can stop and fish on it. I think the case law is pretty clear that, yeah, you can get out there and hang out and hike in it when it's dry. But if you ask DFG or a local sheriff, you may get a very different answer. And you don't really want to sit in jail for the weekend while you're getting ready to exonerate or to exercise your rights. So I think part of that's an open question, but generally someplace like that, it's clearly navigable on Lake Tahoe. And so there's probably not a right to exclude people.
all right, thank you.
Yeah, good question though. I'm trying to write in that area eventually. There's some good articles already, but I think it misses that question of can you hike up this? Can you go in and fish these places if you can get access to them? Like the exact limits of that right are pretty open right now. All right, so what I thought you were getting at was in exercising this right, can you keep other people from exercising their right to the water, which is a different question. And these rights are what we call correlative rights. So they correlate with other right holders, other riparian right holders on the river. But that means that unless we've gone through an adjudication for this specific watershed, these rights are not quantified. So you don't know how much water total you can use in that river at any given point. The general rule is that each riparian can use as much water as is necessary for reasonable use of the water, as long as other riparians are not injured. So reasonableness and injury to other riparians, we aren't going to know up front what that is. And then when you have a shortage, when you're in a drought scenario, all the riparian owners have to decrease their water at the same time. Okay, so they decrease their use, they share the available water. There's no priority like we hear about on other kinds of water rights. So you can't have a better water right than your neighbors do to use that water if all we're talking about is a riparian right. And that means that in a really dry year, you don't have any idea exactly how much water you're going to be able to get until you get a dry year. And generally, you're going to need a dry year, and then you're going to need litigation to figure out how much of a water right you have. And that makes it difficult for, say, an industrial user of water, anybody who needs to know that they're going to have a set amount of water to use at a given point, because they just won't know ahead of time. They won't have any kind of degree of surety or the knowledge that in a drought year at least we get this much, or I'm going to need to go out and find this much more water, because you just don't know until that gets decided. All right.
It's probably a little different on the East Coast because even in the dry years you still have water. It's not going to dry. Most likely, it may not dry up like it is here.
Yeah, so it becomes much less of a concern. This worked pretty well on the East Coast because we had enough water generally. You didn't have to worry about these big dry years when the river may not flow at all. And historically in California, we would have had a lot of years where something like the Sacramento River even would have just minimal flow in it during the summer. Or if you go down to Southern California, you've got rivers that are dry 90% of the time, like naturally dry 90% of the time. So when there is water there, you're going to have a lot of people fighting over that water. And that's part of the problem with riparian rights and why we ended up with coming up with something else in California, because these didn't work very well for us out here. All right, so other restrictions, as I said, no right of storage. Storage is an appropriation of water, so you have to have an appropriative right to do that. You can only get that natural stream flow. And the rights remain with the land when the land is sold. So if you've got something like this out in the country, these are, say, 10-acre plots, and you decide we're going to subdivide that into housing. So we're going to divide it, make nice little housing blocks out of it. The only ones that would keep their riparian right would be those on the very edge right there. So you end up losing a whole lot of the riparian rights associated with that when you try and divide these things. Okay, questions then on riparian rights generally? All good? All right, so appropriative rights, these were developed in the Western United States where, as we were just discussing, scarcity is really the dominant aspect of water. It's a thing we're really worried about. These came out of California. This is one of California's great contributions, is to muddy the waters by creating this doctrine. These come out of mining practices. So I think I'll just show this video, and then we'll go from there. I heard your request for more videos. So. I'm nothing if not responsive to student requests. I was going to just show River Runs Through It and call it good. But
Or Chinatown.
Chinatown is very good.
You could bring him one bag of chips.
Chinatown isn't on Netflix, so.
I'm waiting for a really crappy day, and then I'll bring in the chips. I have Chinatown, I think. I also have Cadillac Desert,
Oh, yeah.
the first one of those, which is really good.
that?
They did. It's like a 6-hour PBS thing,
Oh, really?
which is only available on videotapes, and it's like $600 and some to buy it on Amazon.
Is that the library?
So what I did when I was at KU, it's on YouTube, but it's a pretty crappy rendition,
Yeah, it's pretty.
and it doesn't go in order. Although I showed it from YouTube once, and the students didn't notice that it wasn't going in order. I'm like, I don't really know what that says about them, about the PBS video. Yeah, they were undergrads, so it's a different game, I guess. But I found it at a library, brought it home, and illegally copied it. Risked the federal felony to create an electronic version. So
Environmental on intellectual property.
yeah, it's greater good.
PBS's mission is to
I'm-
broadcast to the
I feel like I'm helping them. I kind of have an ownership stake in that anyway. All right, so this is a great video. The sound kicks on here in a second. It is an old guy. It's pretty awesome. Come on.
Because it's nothing more than a giant open pit. There are no men in here working with traditional gold pans, nor are you likely to see entrances to the great deep mining tunnels of the quartz mine. Because this is a hydraulic gold mine, and as such, It's one of the most historically significant spots in California. The process of hydraulic gold mining is important to California in many ways. First of all, hydraulic mining was born and raised in California. Furthermore, it was the cheapest, most efficient method ever devised to recover gold from the river gravels, where gold is most often found. But to Californians, it has a special significance. It was once the issue of a famous war between the gold miners of the mountains and the farmers of the valleys below. And from that war grew one of the most important concepts of government regulation over private enterprise. Hydraulic gold mining was dramatic. Everything about it was loaded with drama and excitement. But what's most important to us today
Early
is that
hipster.
this chapter of California history is disappearing before our very eyes. Because I'm standing in the last hydraulic gold mine to exist in the California Mother Lode. And when this cannon fires its final shot, hydraulic gold mining will probably die forever in the very territory that gave it birth. Now in 1848, when gold was discovered in California, men came here from all over the world to seek it out. But it wasn't long before they picked up all of the easy gold, and they began to be faced with the fantastic engineering problems of getting gold out of the secret places, where it laid for millions of years. These men were among the most resourceful in the world, and right here on the spot they solved problems that seemed unsolved. Take this problem right here, for example. That hillside is no ordinary pile of rocks. That's the bed of a river that flowed over 30 million years ago, in a time that the geologists call the Tertiary period. And that river carried gold down from the higher mountains. But later, a giant upheaval of earth came along and buried many of these rivers. They disappeared under tons of newer earth, and the gold that was in them was buried as well. This river bed, along with many others, was eventually uncovered by new rivers that cut deep channels, so deep that they crossed the old river. And wherever this happened, a little of the tertiary gold leaked out and gave the miners their first clue of where the gold was hiding. But the problem was, how to get the gold out? There are thousands of dollars worth of gold in that hillside, but also mixed in with millions of tons of river gravel. That's so hard that the miners themselves use gold.
Yeah, day of my life.
The miners knew that if they could just get the gold loose from the hillsides, they could easily separate the gold from the gravel by running the aggregate through long sluices, pushed along by streamliners. They could put barriers or riffles into the sluices that would catch the gold, and yet let the gravel and the mud go through. Because gold is heavier than anything it travels with. And if the sluice was long enough, eventually the gold would drop to the bottom and sagebrush behind the river. But how do you get the mountainside free enough to sluice? And the process was simple once they figured out the necessary equipment. If water had placed the gold in those riverbeds to begin with, why not use water to blast it loose again? Well, that's exactly what they did. The miners fired enormous blasts of water against those old riverbeds and let them roll down through their sluices and over the riffles, carried by this new man-made river. All this was made possible by the invention of a single piece of equipment. And here it is, the key to the whole solution, a water cannon, fashioned after a Civil War artillery piece. These cannons were called monitors, and this particular type was affectionately called a Little Giant. This Little Giant was first built for the Omega mine nearly 100 years ago, and is still being used today by Bill Wilson. It weighs 1.5 tons, and yet one man can make it move as gracefully as a ballet dancer. The trick lies in the ball joint up front on the holds the nozzle.
Goes downstream
The
later.
power to direct the cannon up and down from side to side comes from the backlash or counterforce of the water jet blasting out of the nozzle. As Bill Wilson moves the rods that aid the nozzle, the water stream is deflected, moving the cannon in whatever direction Bill wants it to go. Because of this ingenious power source, Bill can operate this entire hydraulic mine alone. The whole operation, of course, depends on getting a powerful head of water going through the cannon. The water jet that comes through this monitor throws a punch of 5,000 pounds. That's 2.5 tons. It could demolish a building or cut a human being to ribbons. In 1 minute, it throws out 16,000 gallons of water, about equivalent to the capacity of 1.5 railroad tank cars. In 24 hours of operation, this one monitor can move 4,000 cubic yards of gravel down the bank and through the sluices, including trees, boulders, mud, and of course the precious gold. And even though there may be less gold in every cubic yard than 1/4 the size of a copper penny, it's considered rich ore in the hydraulic mine.
Within a couple hundred miles
Amazing
here.
part of this whole
Within a
process
couple hundred miles
is
here.
every pound of water pressure released by this cannon comes from gravity alone. It is literally falling water that drops down from the streams and reservoirs high above us in the mountains. And then it's caught by these iron pipes that are finally fall down to the monitor. This particular pipe leads to a reservoir 1,500 feet up the mountain. Because of the angle of the pipe, the vertical drop is only 250 feet. In some of the old hydraulic mines, the vertical drop was 400 and 500 feet. Water was the great key to hydraulic. First you gathered it high in the mountains. Then you sent it plunging to the mines in closed pipes called penstocks. Here the monitors fire the water against the gold-bearing gravels, washing it into the sluices where the gold was caught by ripples. And it was water that unlocked the gold from gravel, mud, sand, and almost every early mining method: panning, sluicing, dredging, and hydraulic. But this same water gave hydraulic mining its tragic flaw. And to find that flaw, we have to go back to the beginning. The Sacramento Valley in California looks very much like a big, flat-bottomed bathtub, with mountain ranges forming the side. On the east are the Sierra Mountains. Rolling gently into the Sacramento Valley from the Sierra are 4 of the most famous gold-bearing rivers: the Feather, the Yuba, the Bear, and the American. It was up these rivers that the Argonauts of 1849 searched for their first gold, the placer gold. By 1852, a miner named Anthony Chabot had invented the first crude hydraulic technique: a wooden pipe that carried water down the riverbank to a canvas hose. He was able to erode away the softer parts of the bank in this fashion and save himself and his partners a lot of work. It took until about 1870 for the process to reach maturity, with many years wasted in the slow development of monitors and hoses. Eventually, iron pipes were introduced, forged right in the mining pits themselves. And the famous little giant monitor, with its aimable nozzle, was the final piece of perfection and refinement. By 1880, in the 3 most active hydraulic counties alone, there were 41,000 men at work. The biggest of the hydraulic mines was the North Bloomfield, a consolidation of many smaller mines, and an enormous, heavily financed company in itself. Now, what we're talking about is one of the greatest ventures of man, one that literally changed the face of the earth. And this is the biggest and most famous of all of the hydraulic pits, the North Bloomfield's famous Malakoff mine. This ghostly natural monument to hydraulic mining is still such a dramatic sight that it has been designated a California state park. It was the North Bloomfield that first introduced long-distance telephone lines to connect its homes and installed electric lights for 24-hour operation. Although many smaller mines would stop only once a year to clean the gold out of their sluices, the North Bloomfield held a cleanup once a month. The most dramatic evidence of the size and success of the operation here at the North Bloomfield is this replica of a cleanup block they smelted from the hydraulicking of 1 month, January 1882. This block of gold, accumulated from millions of tiny flakes almost powder fine, weighed 510 pounds and was worth over $114,000. In 18 years of operation, the North Bloomfield total gold yield amounted to nearly $3 million. The excitement of hydraulic gold mining reached all the way from the investment circles of San Francisco, New York, and London, right back into the hydraulic pits themselves. One reporter came out from the San Francisco Bulletin in 1879. He may have been standing on this very spot, and what he wrote was very exciting because it made the operation sound like something out of another world. He wrote, "We stand on the brink of the mine and try to fix the salient points in thought and memory before we descend into the great amphitheater, vaster in its circle than the stony base of the Colosseum. As we turn to descend, a measured succession of sounds begin. Far down under the highest cliff, on the sloping bedrock and half hid in the shadow, are a multitude of men. The water has done its work here and washed out all the loose earth and smaller rocks. There's a real pleasure, very distinct but hard to describe, about this gigantic force issuing from the monitors. This is the water that left the reservoir a few hours ago and has been worried and tumbled and beaten into foam until one might easily believe that it comes out not merely with the force of much gravity, but also with a wicked, vicious, unutterable indignation. You hear little rattling and slipping noises through the incessant roar, and the stream, which seems 10 times greater than could have come out of the pipe, flows down the dripping pile, and so into the rock channels which lead to the tunnel. Unfortunately, the reporter who made that account of the great hydraulic pits didn't go quite far enough, because where I am right now is where the trouble began. Behind me and up this sluice is a hydraulic mining pit. Up there, the miners were more concerned with the amount of water pressure they could force through their monitors, the depth of the overburden, the amount of gold per cubic yard or per ton of riverbank, the number of riffles they needed to stop the gold but let the tailings go on through. But at this point right here, the miner lost completely his interest in the process. From this particular ledge, for example, these tailings dropped 1,200 feet into the American River below. But then what? It was what happened at this point, with this great tide of sand and mud and gravel, after passing through the sluices and the tunnels, that finally choked hydraulic gold mining to death. These were the tailings, the tragic tailings that crept down hundreds of canyons like this one to the Sacramento Valley, until the mouths of the Feather, the Yuba, the American, and the Bear Rivers became great glaciers of mud. In the 1870s and 80s, these rivers were carrying millions of tons of hydraulic mud down from the tailings of the mines. And as the fast mountain rivers slowed down in the Flat Valley, the mud settled and began to build up year by year until every little rise in the river level meant a disastrous flood to the valley people. During the 20 years of the most concentrated hydraulic mining, the bed of the Sacramento River rose 16 feet. River traffic became impossible. San Francisco Bay turned brown the year round, and on the farms outside of the river towns, hundreds of acres of fruit orchards were strangled. Roads disappeared, fences were buried, houses filled with mud. And here in Marysville, one single flood left 3 feet of mud down on those streets. The Sacramento riverbed was once higher than the streets of the city. Because of these levees, Marysville and Yuba City are called the walled cities. And actually they have been, more than once, like cities under siege. Mud was the cause of the bitter war that the farmers fought against the miners for their very existence. Fortunately, most of the battle was fought in the legislature and the courts, but it was a long and mean fight. The farmers tried to get injunctions against the miners and failed. They sued the miners and failed. They built levees that burst. But in 1880, the farmers succeeded in getting the legislature to appoint a state engineer to investigate. Now, his final report was terrifying. He came back with the news that every canyon was choked with mud, waiting for the rains to break it loose. A glacier of mud hanging over the valley. Some canyons were 100 feet deep in mud. 70 million cubic yards of it in the Yuba and Sacramento canyons alone, waiting for the final push. an annual flood was inevitable. It was clear that action had to be taken, and eventually it was. The final judgment came down from Judge Alonzo Sawyer in January 1884. His decision was so complicated that it took 3.5 hours for him to read, but the word was final. All tailings must stop. And when the people down there around the telegraph office got that message, this little town went wild with joy. The church bells rang, there were steamboat whistles, people cheering in the streets, houses draped with bunting, cannon salutes, fireworks, and an enormous bonfire. The war was over. The mines must close. And the people in the valley went
Second Amendment.
Like, Sean, get the cannons, finally!
Who the hell was sentenced to death.
You haven't spent much time in Marysville, have you?
I have, it's like, Mom Happy brought this back from the Civil War.
The buildings around me here are what's left of the town of North
The
Carolina.
AR-15s now.
It closed down along with the
That makes
hydraulic
sense.
pits, like so many other towns of this here. As the farmers had suffered for years under the slickings of the mines, now it was the miners' turn to feel the pain. Employment ceased in the mines, and one mining town after another became deserted. A new term came to these mountains, ghost town. California had made its decision. Hydraulic gold mining will become one of the great legends of California. It was a tribute to the Argonaut's ability to harness nature against herself. As the farmer set his plow into the earth to grow his crop, so the miners set the rivers against the mountains to harvest food. Hydraulic gold mining did not die because it was inefficient. It died because it served so few and injured so many. To us and to our children, the hydraulic cannon will become the relic of a forgotten war. Today, below the silent Sierra cliffs, only the battlefield remains.
All right. It's a really, I like the video. It does a good job with it. So if you go up through Marysville or Oroville and you see these areas, you can actually still see the mine tailings all over the place. Let's see. There we go. So these, we've got the Feather River right here. Oroville Dam is upstream from this. These areas all on the side are all mine tailings. These are all gravels that have been washed out of the Sierras and then generally were reworked early in the century to get any leftover gold that was in there. But so you've got the river, there's actually tailings kind of all around the river itself. But then as soon as you get away from the river, you get into these big areas that are just a series of piled up tailings. Let me zoom out a little bit where you can really see it. Yeah. So you've got pits, and then between the pits you have big piles of cobble, and the cobble's all about that size, and it's everywhere in there. And all of that was originally up in the mountains and was washed out via that gold mining. So pretty incredible to be able to see that. All right, so the way this worked, I think I got a pretty decent description already, was we have the Sierras, a little man over the Sierras are rising up. We've got magma down underneath that's from melted seafloor that's raising up here, and that's hot, so it rises, heat rises, hot rock is less dense than cold rock. So as that raises up, you get cracks, you get fractures forming through the overlying continental crust, and there's water, a little bit of water mixed in, usually inside this rock as it's coming up, and that water will follow those cracks up, and you'll get water coming out, hot springs, that kind of thing. That water will have dissolved gold in it, have quartz rock essentially dissolved in it, and so as it moves up these faults and cools, it deposits gold alongside there. That's why you often find the quartz and the gold together. They're both dissolved in that superheated, really pressurized water, and as it loses some of that pressure and some of that heat, you get crystallization and precipitation of the minerals it's carrying, and that forms that quartz and that gold. Okay, so we get gold in here. these keep going up, we get rain coming down. That's a cloud, not a tree. There we go. Rain coming down washes this stuff down, that frees up this gold, washes that down into the rivers. So you get kind of gold depositing all along here. And then as this keeps going up, we end up with a situation where now we've got mountains here, we've got big piles of old sediment along the sides of those mountains. This is the sediment that was over here, and the rivers have cut down through that sediment, so the rivers are in canyons inside of this old river sediment. And so where they've cut down, kind of an overhead view, or maybe a front view, and you've got the sides either way here for the canyon, but then this stuff, which is kind of flat on either side, all of this is old cobble, river cobble on the sides, and all of that has gold in it. And so what you're doing with that hydraulic mining is just wiping out these big stretches, so big sections of this, and then it gets washed into that river and washed out into the valley where it fills up those rivers. Like I said, 16 feet of additional material essentially on the bottom of the Sacramento River. When you put a permanent 16-foot base in the river, it's not water, it's rock. That means when you put more water in, instead of the water staying in a river channel, it's going to flood. And so you get big floods like the ones they talked about in Marysville and Oroville, Sacramento itself, kind of throughout the valley. So this is where the gold was. This is how the mining worked. That question about how do they get the water pressure is kind of an interesting part of this. So we've got our hydraulic cannon. We want to shoot water out of that cannon. Here's the dude.
He's right in the bowl.
Yes. That's great. Yeah, I'm not gonna. Okay. Imagine the water.
Again.
Yes. Screwing Mother Earth, right? So to build up that water pressure, we don't have a pump that's pressurizing this. The way that you get that is from gravity dropping it down, which means if you have a river, here's your river, you can't just run a hose straight over to the river and get water out. There's not going to be any water pressure there. So to get that water pressure, you've got to go way up. They said the one that they're showing us was 1,500 feet higher up in elevation than where they were. So someplace up here, you've got to build a dam or put a hose in, whatever it is, stop the water up here and then bring that water way down in order to get the water pressure you need to do the mining. Without being able to get water from up here to use down here, mining's not going to work. So with a riparian right, is this the kind of thing you can do? Yeah, it just doesn't work with a riparian right. The other problem is that these lands that we're mining are public lands. You get a mining claim, but it's still public lands with a mining claim on it. So these folks who are doing this mining did not own that land. That land still belonged either to the federal government or to the state government, depending on exactly where you were. But these folks didn't own it, and without an ownership right, you can't get a riparian right. And so they had to come up with a different way to allocate that water. And that's what we're going to talk about. That's the origin, really, of these appropriative rights. Okay, so riparianism doesn't work. Mining practices that we're doing are using tons of water. They may even be outside of the watershed, so we can't just do it through kind of traditional riparianism. Here's a nice example of all these old layers of sediment that the river has now moved away from, and they're just blasting that out. That's the Malakoff diggings one, which we visit on the Cases and Places trip. So the way that this developed was to follow the same kind of general pattern that the miners used. If you want to come in and you want to stake a mining claim, you've got to find a spot where somebody else hasn't already claimed that land. Whoever claims it first gets it and gets to use it. So we can talk about like kindergarten rules, right? Finders keepers, or we call it more formally, first in time is first in right. And that's what they used when staking these mining claims. And so when they started trying to figure out how to allocate this water where riparianism wasn't going to work, they used the same principle. So whoever starts using that water first gets to use that water. They are the prior appropriator. They have what we call a senior water right. So later users, somebody else who comes in a couple of years later and says, I want a hydraulic line too, I'm going to put my thing in here and run it over here. Mine on this side. If this one's the first one that was set up, that's the senior one. If this one was set up after that, that makes that the junior water right holder. If this one was set up first, then it would be the senior water right holder. Even though it's downstream, where you are in the stream doesn't matter. What matters is the time you were set up, right? So when you first started using that water. So prior appropriation is the big thing. Later users can be limited or stopped in a dry year. So the amount of water that's available for the second user depends on how much the senior user is taking. And that senior user gets a water right. So we'll say that this one's senior. The size of that right is determined by how much water they started using when they first started using that water right. Okay? So that determines how much water they get. And then in a dry year, this senior user can make this junior user stop using water if it cuts into the amount that's available for that senior water right user to use. If it keeps them from using the full amount that they have a right to, they can cut off the junior user entirely. Okay, so that's how those appropriative rights work. Senior appropriator is called placing a call to cut off the junior one. And the senior right holder is limited by the original use, and you can't expand it as part of that initial right. If you expand it, that's a new water right, and it's limited to what you expand it to. Yeah?
You mean like use and how they're using or how much?
Traditionally, it's the kind of use that they're putting it to. And this has changed under different states, different doctrines. But traditionally, it was you're limited to the kind of use that you were putting it to. We limit this kind of traditional approach. Today, cities, water districts have to have water. People need water to drink. So we have all kinds of things that limit the ability of a senior right holder to cut off junior right holders.
So like when I was working at the city attorney's office, they were saying that Sacramento has some of the oldest water rights in California. So do they are they senior right holders, or do they get rights from senior right holders?
So they could get somebody else's senior right, or maybe they have Pueblo rights. And I'm not sure exactly what Sacramento has. There's the really old ones that were not one of the ones we're going to talk about, although Professor Harder might talk about them, that came from essentially Mexican land grant rights. So if you had a city, you got rights associated with that city.
The only Pueblo rights in Southern California.
Yeah, okay, so not up here.
LA, right?
There we go.
I think they just have appropriated in groundwater, but they're really old appropriated.
Old appropriate rights, that'll do it. So you get Pueblo rights that are really old, you get Native American water rights that go back to time immemorial, which are really old, and then you get the early appropriative rights, like pre-1914, and then the newest rights, the post-1914 water rights. But as I said, Professor Hart will go into that in a little more detail. Yeah?
With the California system that's set up where riparians still have priority over appropriators, how did this work for a riparian who had a right to have so much water coming through down there, but instead they were getting all this sludge?
Yeah. So up high, at least, it wasn't an issue. There just weren't many riparian rights holders that were way up in these canyons. I mean, think about when we drove in to look at the Malakoff diggings, nobody was living in those canyons, right? That's not an easy spot to make a living. And they were more concerned once you got all the way down about the problem of too much water. Certainly, you'd run into issues, but I think there were lots of court battles. This was like, when we say it's like the Wild West, this actually was the Wild West. So I don't think I don't have at least a good answer for that one. But you could ask Professor Harder, see if she knows a little more about the history of it. Other questions? It's great because I can just duck all of the questions and pass them all on to her. All right, so to get this appropriate water right, there are elements you have to have, 3 elements that you need to have. You have to have an intent to create a right. You have to have diversion of the water, including physical control of the specific amount that you're going to use. You can't just leave it in the stream. You actually have to take it out and physically control that amount of water and then put that water to beneficial use. So it used to be that you just put up a notice, right? If you were a miner, you just tacked up a sign, I'm going to take this much water out of this creek and use it for this purpose. You'd start using it, and that was enough. You had a water right. Okay? We have a much more formalized system now, but historically, you just provided notice, and then you went forward with it. So there's a nice case on this point. It comes out of California. Caltrout Incorporated versus State Water Resources Control Board, 1979 case. Caltrout was trying to protect in-stream uses, and so they were trying to buy water rights or get water rights to keep water in the river, to keep the fish in the river happy, healthy, able to be caught by all of their stakeholders. And the court says the entire history and origin of the development of the doctrine of appropriation of water in California demonstrates that appropriation of water in the legal sense involves possession of the water. You have to divert it, physically control it, You can't just leave it in the stream. So we can't protect in-stream rights through appropriation of water to protect those in-stream uses. We have to have other ways of protecting in-stream uses of water rights. So diversion and use is the key. It's considered appropriated once it's diverted and used for the intended purpose. Notice was not required, but generally was given, just because it was easier to enforce your right if other people knew about it. And you had to actually construct a diversion, actually had to put it to use. Water that's diverted pursuant to this appropriative right, like we see here, can be used away from the stream, can be used in a different watershed, so it's not subject to all of those riparian rights that we see. You don't have to let this water keep going downstream for riparian users. If you're looking at these systems and thinking that riparianism and appropriative water rights don't fit very well together, that's true. And most of California water law history is trying to hash out some kind of compromise between these different water rights systems. So initially it was a limited state role, really the miners just handled it on their own. We start seeing some legislative approval of this in California not too long after it starts, this kind of generic approval, and then the courts say, yeah, this seems to be an okay way to do it. And then finally we get the Water Board in the authorizing legislation in 1913 really starts operating in 1914, and they create this permit system, but the state authority was viewed as ministerial. So the state, if there was water in the river and you asked to use that water, the state had to let you use that water. The state couldn't weigh other uses, couldn't say, yeah, but these fish are in trouble. There was none of that. It was just, if there's water, you give notice to the state board. That's all you have to do. You can start using that water. Once you start using it, you've proved up your water right, and that becomes your appropriative right. All right, so there are some things you have to worry about here that you don't have to worry about with riparianism. If you, so you have your right, you can lose that right through prescription. So this is prescription in a property sense. Y'all remember from first year property prescription? Open, notorious, adverse use under a claim of right for 5 years, then you get to use that water. Kind of adverse possession of a water right. So taking somebody else's water, if they don't complain, that water becomes your water. You can't do it to the government, but you can do it to everybody else. Abandonment, if you don't use that water, if you give up and you walk away from your mining claim and you stop bringing that water down to spray onto the hillside, then you give up the right to that water. No matter how old your water right is, if you don't use it, if you abandon it, you lose it. And if you don't use it at all, if you don't use it for 5 years, then that water is available for others to appropriate, and you've lost your water right. And the reasoning behind this is the same. We talked about this comes from those mining claims. If somebody disappears from the mining camp and their claim doesn't get worked, after 5 years, that claim becomes free for other miners to take it. The goal is to get this gold out of the ground and not being able to keep track of people not having really a good system to record these mining claims or anything. We had to have some system, some way to make sure that land's going to get back into circulation if someone disappears. And this was the approach that folks took, follows on the kind of Western tradition of abandonment, Western tradition of prescriptive use of property. And here it just plays into the water rights system. Questions on that? All right. Yeah, so you can take these rights through condemnation. A city can come in and claim these either through by condemning them or through eminent domain. You have to pay for the takings if you do that. Because they're not tied to the property, you can take those rights as a city away from an individual, which you can't do with the riparian rights. The other part of this is there's not any inherent protection of the public interest. There's no inherent consideration of the public interest. That's something that has to be grafted on top of these appropriative rights in order to get that kind of thing considered. So some differences with the appropriative rights. Land ownership isn't required. As we said, these folks didn't own the land when it was first developed. Water can be used a long way from the riparian lands. Owens Valley is a great example of this. Owens Valley water is taken, almost all of it is taken down to Los Angeles. I think it's actually 300 miles from LA. And so it's way outside of their basin, way outside of that watershed, and they bring it down for drinking water use in Los Angeles. The appropriator has to have legal access to the diversion site, so there has to be a way to get to that water, but you can get that through a prescriptive easement if it was existing before that property was purchased by somebody else. If it's public lands, you can just go over those public lands. The other part that's a big difference is that this is not a correlative right. Remember, if you have the riparian rights and you have a bad year, everyone's rights going to be reduced. If you have a whole bunch of these rights, a whole bunch of appropriative rights on the stream, and you have a bad year, your junior users are going to lose all of their water, and your senior users will keep more of their water. So whoever's most senior gets to keep that water. And that tells you, if you're looking for predictability, you're going to have a much better idea of how much water you're going to have in a bad water year. If you have a junior water right, you're going to know that in a good year you've got water, in a bad year you're not going to have water. And so you can plan accordingly in terms of what crops you put in, what industry you're trying to use that water for, whatever it is. As opposed to that riparian right where you're just not going to know ahead of time, one way or another, how much water you're going to get. All right, all good in riparian water rights? Cool. So federal reserved water rights, last one. Whenever the federal government reserves land for a purpose. So remember we talked about public lands. Initially we're just trying to give all that public land away. And then starting in the 1890s, we get reservations. We have the ability to, first it was forests, we're allowed to reserve land for forests, Native American, Indian reservations, and then we get a whole bunch of other uses, right? National parks, wildlife refuges, all of these things kind of come creeping up as the United States starts to think about how it's going to manage all this land that it's not giving away. And so we have a big Winters case. This kind of creates a Winters right. We call these generally Federal Reserve water rights. And these Federal Reserve water rights are created when the federal government reserves public lands for whatever the use is, right? Indian reservation, military, national parks, forest, monuments. It implicitly reserves the water sufficient to serve the purposes of that reservation. So if you reserve a national forest, you're inherently reserving enough water to support the use of that land as a national forest. Okay, national park, preserving wildlife, you're reserving enough water to use to run that place as a national park, to keep the fish in the stream alive, kind of all of those uses. So Federal Reserve water right quantification limited to the primary purpose of the reservation and to the minimum necessary to fulfill that purpose. So it's not all of the water in the stream, it's limited to what the primary purpose is of that reservation. So as we said, national forests, you need enough to preserve timber resources and water flows. If you have another federal use, you can't just rely on these Federal Reserve rights. So in California, for example, when we built Friant Dam on the San Joaquin River, the federal government had to go out, Bureau of Reclamation had to go out and get appropriative water rights for that dam, for all the water they were going to store there. And there's a lot of downstream folks who were using that water who were already appropriating it via pumps to pump into their field, or who were riparian right holders. And so they had to convince those folks downstream to give up their rights because they were going to be stopping their water upstream. And so actually, they traded a bunch of those downstream folks now get water from Northern California, and they divert the Friant Dam water kind of along the eastern side of the San Joaquin Valley. And so they get water, the Bureau of Reclamation went in and traded to get those water rights they needed to build that dam. Does that make sense? So generally, federal government is still constrained by state water systems. And the priority date on these is the date of creation of that reservation. So when you reserve that right, that's the age of this reservation. And interestingly, you can get a Federal Reserve groundwater right. So the Devil's Hole pupfish, anybody heard of those things? Super cool little pupfish. They live in this place called Devil's Hole. It's maybe half an hour, 45 minutes east of Death Valley. And
Oh, yeah, here we go.
there's
Video on this?
lots of video on this.
There's a cool one where there's like an earthquake somewhere else and the water starts to move.
Yeah,
Is
so
that the one
there's
that you showed us?
in Japan when the big earthquake happened, there's actually a 6-foot wave in this little hole in the ground that has this groundwater in it. Nothing fell on the surface, and all of a sudden the water just starts sloshing in this pool. All right, so here's the ground. People hanging out up here. All right, there's your truck. They put up barbed wire because of all the yokels of the trucks. Down here we get a little fish called a pupfish. This whole area, that whole basin area, used to be underwater. As we kind of got out of the last glacial period, that water is largely dried up. Leave places like Death Valley, big inland seas that are very salty. Mono Lake, another example. The Salt Flats, Bonneville, all that stuff is kind of the tail end of these big inland seas. There are pupfish that live all over these lakes. The tiny little cute fish that swim around to eat baby mosquitoes, give live birth. But as the water went down, we end up with overhead view on this side, a whole bunch of different lakes or streams or springs that stayed wet. And so each of these little springs or streams or whatever has a population of pupfish that live in those. And because they're all separated, they all undergo speciation, and we end up with a whole bunch of different species of pupfish. So these things, each little spring has its species of pupfish that's found only there, and it's completely unique, and it's different from all the other pupfish anywhere else. And it becomes a problem because we have pumping that goes on. So big pump over here, sucking water out. And when this happens, remember the groundwater discussions we've had? You get a cone of depression that forms around this. So this is the groundwater level. We get a cone of depression that forms around that, and that cone of depression started impacting Devil's Hole. So we've got our little fish in here. These things are tiny. They're like 2 or 3 inches long. They're really cute. They're bright blue. These guys live all over, and there's actually, so there'd be dragons here. That's what they used to write on the maps when they didn't know what was down there. We have no idea what's underground here. The National Geographic sponsored some folks to go in at one point. They got down about 200 feet. And they said, that's far enough. We're not going any farther. They came out. We know there's some other big chambers where there's the water with air exposed above it. We've lost people down there who just got lost scuba diving and not come back after losing a couple of people. That's the reason they really put these in. We know the Devil's Hole pupfish at least live right here, but what they need is this little shelf. That's where they spawn, and you get this, it's probably higher in the sky, but that's the sun. And when it shines down, it grows algae on that little shelf. So warm, algae, great spot for the pupfish to live, great spot for them to spawn. But when groundwater is getting pumped, that groundwater pumping was dropping the level so that it was below that shelf, and that meant the pupfish couldn't spawn, pupfish start dying out. So there's a farmer over here who was going to develop his land into a big subdivision. It's kind of a problem because there's not a lot of water for subdivision anyway. But the idea was a lot more groundwater pumping, and so when this farmer started trying to go after that water, the U.S. government filed suit, and the court said that when they reserved this land, right, and reserved this land for the purpose of protecting the Devil's Hole pupfish as a wildlife refuge, we are inherently reserving enough groundwater to keep that shelf underwater and keep those pupfish alive. Okay? Yeah?
Oh, I just wanted to add that, because I just wrote part of my paper on this for Cases and Places. And a recent court case, the Agua Caliente versus Coachella Water District, extended this type of right to tribes where it didn't exist before, wherein a tribe had surface water rights, but not groundwater rights, and they'd never exercised those groundwater rights in any way, shape, or form. They'd never drilled. Now, the Ninth Circuit gave them the right to drill, where none had occurred before, like carte blanche,
Wow.
basically.
That's a lot of water.
It's about to go up to the Supreme Court. Supposedly they're going to take it up. It will be the first tribal groundwater rights case that they've ever heard. But it's based on this premise that the federal government reserved the rights for them to use water for the purpose of the original reservation. And in order to do that, they need to drill, even though they've never done that before.
Brandon monkey wrench and signature.
Yeah, that'll be really interesting to see how that plays out. That's the other thing that's weird about that Winters case. You go back and look at all the Indian law from 1908, and generally they did not get a good shake, right? You're reading these treaties, and you're like, we didn't mean it when we said you were going to be a nation. We didn't mean it when we said we were going to give you these lands. So it's just like anything the Native Americans asked for, the court's like, no. Really? You thought? No, we're not going to do that. Sorry. Just kind of running roughshod over them, and then you get this water rights decision that says, yeah, actually, when we reserve this land for tribes, we reserve water too, and it kind of cuts against the grain of all of these other decisions.
Just as far as getting down into that hole, I can tell you from my experience that 200 feet is the deepest that you can go without bringing more tanks that would fit through that hole, based on the size of the
It's
hole.
bigger than this looks right here. but,
But
yeah.
it's not very big.
No.
People who go more than 200 feet, they're bringing like helium and argon and all sorts of different tanks of different air mixtures.
It's a super cool system, and it's a crazy big aquifer down there. It connects over to Death Valley, which is 100 miles away. And
They can't send a camera down there?
Well, yeah.
they haven't.
Isn't there one of these type of situations, is it in Australia or in South Africa where it's so deep and people die trying to get down there all the time? What is it called? It's
I
like,
don't know.
There's one near Cousin.
but it's like the same principle that at
So
some
what
point
you're
even a
saying is
camera can
Atlantis is
understand
down there.
the weight of the water, everything gets crunched.
I'm sure we could bring like Alvin, right?
Yeah.
Get it in there. But maybe there's tight spots within it. I don't know.
Didn't some kids break into this place and like one of the guys that they were shooting locks off of
Just
the
like
gates.
in the last year.
Yeah, and then like, they actually went into the pool and there was video. They had like a live feed camera in the pool, and they like recorded these guys mucking around down there.
Yeah.
Fuck, it was cool.
Yeah. No, it's desert folks. It's like the what are the
There's actually a
creatures?
video right here.
Phantoms? Is that the ones who are from Star Wars with the long guns? Never mind. The desert people. The sand.
The Tusken Raiders.
Yeah, there you go. Now and you actually, so when you're doing, there's a NEPA connection here too. When you're doing NEPA analysis, you have to anticipate events like that. Just like the general knowledge that people are going to be assholes and do bad things. We were dealing with a desert tortoise lawsuit, and it was a question of whether opening additional lands to off-road vehicle use, what impact that would have on desert tortoises. And we know that when off-road vehicle people go into an area, the number of tortoises that are just randomly shot because they're like crawling across and it's something to aim at in a big empty desert goes way up. Or tortoises just getting turned over and left there to die goes up. And so you actually have to factor that in when you're doing a NEPA analysis as like the part of the impacts of that decision. Yeah, the human evil category of NEPA analysis. All right.
You should call it that.
I don't think they do, but it would be.
People are the worst category.
Yes, exactly. All right, so we've talked about the three different kinds, major kinds of water rights. There's some other fairly minor ones that we're not going to cover too much. And so let's talk a little bit about the systems that different states decide to adopt. Again, this is decided by state law, not federal law. It's a property rights issue. And generally, we find that this is determined by the nature of the state that we're looking at. So very few states are purely riparian because, if we talked about, you don't know how much water you're going to have. There's a lot of uncertainty there. When you have a shortage, you'd really like to know right away how much water you're allowed to use. And making folks file a lawsuit during a water shortage doesn't work very well. Breeds a lot of litigation, discourages investment in water resources, and just like the appropriative water rights, it doesn't inherently protect those public interests. So we see very few purely riparian states. What we see instead is a form of regulated riparianism. This is mostly states that are east of Kansas City, so mostly states in the eastern United States and Hawaii. So this is that 100th meridian line drawn on here. So like we said, these are the wetter states. And if we map on our doctrines, our dominant water rights doctrines, you'll see that this darker hashing, that's the riparian states. So all of these states use a form of regulated riparianism. And then the dots are the appropriative states. So our kind of very driest states use almost a pure appropriative system. And then the white states here use both appropriative and riparian rights. So blended system here, blended system here. Nebraska's actually divided along that 100th meridian. Eastern half uses riparianism, western half uses an appropriative rights system. So it really does track that line pretty closely. So those eastern states, 19 of the 31 states east of Kansas City and Hawaii, use regulated riparianism. So riparian principles are the main way we decide this, but you add public management, you add a requirement to get permits, so you have a certain degree of certainty about how much water you're going to have. The idea still is that water is a public resource managed by the state in a trust for the public. We allocate it through these permits based on riparian principles. Generally, the permits last 10 to 20 years, and you have to go back and renew that permit to use the water. The state can look at that during that re-upping of your permit to make sure there's enough water, there aren't other users who need to use some of that water. in order to address changing needs over time. But here, the water rights are held by riparians. So it's still a riparian approach, but just with an added degree of state regulation in there. All right, pure appropriative rights, Colorado doctrine is what we tend to call this now. Very rare that we see these purely appropriative states, but the states that essentially run along the spine of the Rocky Mountains, right, so Colorado, Utah, Nevada, Utah, Colorado, Arizona, Idaho, Montana, our very driest states still use this essentially pure appropriative rights doctrine. There's some riparian rights may bleed in a little bit, generally for non-consumptive uses, not uses where you're taking water out. But this is coming out of Colorado court. There's no such thing as a riparian right to use the water as against an appropriator. The appropriators dominate, and their rights take precedence over any riparian rights. Some states add in a public trust angle, and we'll talk about that later on, or other state laws to keep some water at least in the rivers, some like minimum in-stream flow for environmental purposes, but that doesn't inhere in the rights themselves. That's something else that the states add on to it. All right. And the third system we see is the hybrid system. This is called the Oregon Doctrine. This came initially out of California because we have up in the mountains, which I've erased now, that appropriative rights being born, and then we have riparian rights existing on the valley floors, and so we end up with this hybrid approach of both rights. It's called the Oregon Doctrine. We kind of call it the California Doctrine, but the rest of the country calls it the Oregon Doctrine because it was first adopted by the legislature in Oregon. Our courts had created it, but Oregon's the first one that had a legislature. They got on board with it. This covers Pacific coast states, and then those states kind of right along the 100th meridian where you get a blend of areas that are too dry for ag and areas that have plenty of water. So all these mixed climate states end up with kind of a dual rights system where you have both riparian rights and appropriative rights. So Oregon adopted this, as I said, in 1909. When they adopted it, they abolished all unvested water rights, and so they got rid of any riparian rights that were not vested yet. California in 1915 adopted legislation creating the State Water Resources Control Board, but it did not abolish the riparian rights, which makes ours a little bit more complicated than what you see in Oregon. In Oregon, any new right had to come via appropriation and needed to have a permit from the State Water Resource, their version of the State Water Resources Control Board to do that. A lot of states follow that dual system. That's a lot easier to do than what California has done, which is what Professor Harder will cover next time. And that's it for me. We're actually done early. Happy day after Halloween. Go home and eat some of your leftover candy.
Oh my god. I got like 3 trick-or-treaters, so now I have to eat all the candy.
So
You have to?
I have to.
It's a mandate.
Monday night, I was like, I'm going to eat a bunch of candy tonight, and I'm not going to want any tomorrow night. I ate like 3 pounds of candy Monday night. It was terrible. I was just like this giant wasteland of wrappers. I felt so bad Tuesday, but I'd recovered by Tuesday night, and so I had another 3 pounds of candy last night. It was terrible. Jack was a toilet. It's pretty sweet. We should have made him low flush. And then Anna was a pioneer. I'll show you the picture.